Hey there. Did you know that over 25% of the world's CO2 is found in oceans? That's crazy. To solve this, I replicated Christian Asher's project to reduce CO2 levels from water with heat. Now first, you may be wondering, how come we want to remove CO2 from oceans in the first place? Don't marine life and aquatic plants need it to survive? Now, although they needed to survive, if they have too much, it can be bad for them, as marine life can start developing an oxygen deficiency, causing them to gulp air, and pH and KH levels will start to increase. And if the levels are too high and marine life aren't able to adapt to the new environment, they can start to die off. During this project, I learned about water solubility, the power of carbon capture solutions, and I broadened my knowledge of carbon capture solutions. I first had to create CO2. To do so, I made a mixture of a base which was sodium bicarbonate and diluted acetic acid. In this reaction, the water acted as a host for the acid and base to react. The sodium bicarbonate took one proton from the diluted acetic acid, and then CO2 was released as a byproduct. The gas then rushed out of the bottle into a container filled with water to dissolve with the water, forming carbonic acid. The carbonic acid is a dibasic acid with the chemical formula H2CO3, which releases its CO2 at around 60 degrees Celsius. To release the CO2, the carbonic acid was then transferred into another container where it was double boiled to release the CO2 from the carbonic acid. Now, for the most important part, the final reveal. To test if CO2 is actually being released from the water, I used the solution of water and calcium hydroxide to form lime water or calcium carbonate. Calcium carbonate is a solution with the chemical formula CaOH2, and when CaOH2 is mixed with CO2, it forms CaCO3. CaCO3 has a cloudy white appearance. So if CO2 is actually being released into the lime water, the CaCO3 would have a cloudy white appearance, which it did. Success! During this experiment, I learned that this solution wouldn't quite be viable to reduce the CO2 concentration of oceans, as it requires the body of water to be heated, which would be very challenging as it would be resource intensive to warm up a large body of water such as one of the oceans. It would also cause great environmental concerns, as heating up the oceans is the opposite of what we're trying to do right now. I also learned that lime water requires a great concentration of CO2 to become cloudy. Next time, I would reduce the quantity of lime water and I would increase the saturation of CO2 for a bolder demonstration with cloudier lime water. If you enjoyed my findings and would like to go more in depth in them, please check out my article linked below. See you guys in the next video where I'll be demonstrating another carbon capture solution. Bye!